Let the complete solution of equation number 1. Remember this?
Yeah.
What is that? How many variables are there? There are
Of
two
x
variables.
comma t is a function
Two
of
variables, x comma t is equal to, here x is a function of x and t is a function of t. The same way, whatever we have done it in the last sequence, same thing will be repeated here. We called it as equation number 2. It is. Now find out these two values, this one and this one. First of all, I want to find out dou u by dou t value. Dou u by dou t means differentiation of u partially with respect to t. Keeping x as it is, you will get it x t dash and dou square u by dou x square value. Similarly, we have to keep it t as it is and then derivative of x 2 times x double dash of t. Now take these two values in 1. Put the value in equation number 1. Put the value in 1. What is this 1 becomes? Tell me, what is this x becomes? Here I will write it x t dash is the value of dou u by dou t is equal to c square will be a constant, of course. Okay, and this value is what? X double dash into t. The inner function will be x. We are not going to write that. We can neglect as no problem. By separating the variable, by separating the variable, it means that we have to write down the like terms in one side. Okay, the terms which are containing t, we take in one side t dash, and the constant term with the c square with t will be taken in one side. Then x double dash divided by x in one side. And these two quantities are equal if and only if it is equal to some constant. Okay, assume that constant will be equal to k. Your choice, you can either assume with lambda also, no problem at all for that also. Then there are two cases arises. So case number 1 is t dash by c square into t is equals to k, or this implies you can also write this one as, how to write, tell me? T dash
so t dash
by t is equals to c square into k, or this much is enough. We can integrate and we get the answer. One part, this is called as equation number 3. So we use another color for this to understand, because it is using geometry. Number 3, equation number 3. Next case will be same, assuming with x is equal to k, is equal to k, and then again cross multiply. Okay, then we'll get x double dash minus kx, or is equal to kx. Okay, x double dash is equal to kx, or minus kx is equal to 0. We take this as equation number 4. Equation number 4. After this one, 3 cases will be arises depending upon the value of k. Like already we have done in wave equation, same concept will be repeated here. There are 3 cases arises for constant k. 3 cases arises for constant for constant k. We have to deal those cases one by one. For that, I want to use next page. Next page. So case number one. Case number one, when k is equal to 0. When k is 0. When k is equal to 0. Then what happens to this equation number 3 and 4? Look at this. If k is 0, we'll get what? T dash. We can cross multiply. If k is equal to 0, here only we simplify. Both are same only. These two equations are mathematically same. If you put k is equal to 0 and cross multiply, you will get t dash is equal to 0. Right? That is another equation is a simplified form. You can use it later on that. T dash is equal to 0. And if you integrate, what's the answer you will get? T is equal to, what is that? If you integrate, you have to add a constant.
Yeah.
T is equal to C1 in first case when k is equal to 0. Another equation number 2, if you see with this equation number 4, again k is 0. X double dash is equal to 0, correct?
Yeah.
X double dash is equal to 0. Now this implies if you integrate, you will get x dash is equal to some constant. Don't take C1, already C1 is over, take C2. This implies if you integrate one more time, you will get x is equal to, since x is a function of x, you will get here C2 of small x plus another constant after integrating. That constant will be called it as C3. So when k is equal to 0, we got the value of capital X and capital T, which is also a solution of that equation. So we write, therefore, the complete solution of equation number 1 when t is equal to, sorry, k is equal to 0, u of xt is equal to, what happened? C1 into C2 of x plus C3. C1 into C2 of x plus C3, called it as 52. Next case, when k is a positive number. Case number 2, when k is equal to, when k is positive, when k is positive. Let us assume that, k value is equal to p square, where p is any number, where p is any number, p is any. What happened when I am taking k value is equal to p square? Where we have to substitute? We have to substitute here. Here.
Yeah. Method.
Here I am substituting. So when k value is p square, you will get t dash by t is equal to p square c square, correct?
Yes.
T dash by t is equal to p square and the c square. Now, then integrating. We don't want to mention here, that is understood. Integration differentiation of denominator is the numerator. We write it as log t. Log t is equal to, what's the integration of p square c square with respect to t? We'll get p square c square into t plus some constant we have to add. Correct?
Yes. Yeah.
Okay. Then this implies that when log will go that side, you will get e to the power of this value. So then t is equal to e to the power of p square c square t plus c1. So this is t is equal to we have to break this one. The break will be like that. E to the power of C1 is one break. E to the power of P square, C square, T is another break. Can we break it?
Mm,
Bases are
no.
equal,
Yeah,
power
we
should
can
be
break.
added. Bases are equal, power should be added. So for our convenience, instead of writing e to the power of c dash, for my convenience purpose, I want to write this one as c dash. You can take as a also, but in textbook it is given as c dash. So I am using also this another terminology, that is c dash. E square p square t. This is your first answer in terms of t. Now
Yes.
b, another case. Look at the previous case. Again k value we have to write as p square. So our equation will become x double dash minus p square x, right?
Yes.
X double dash minus p square into capital X is equal to 0. So this implies that we have to convert into differential equation higher order format, that is d square minus p square into capital X is equal to 0. And compulsory we have to mention that what type of value you are taking as d. D means here it is d by dx only. D by dx only. Now after that, this is a what operator form of second degree higher order linear differential equation. If you want to find out the solution of such this type of equation, we have to find out its auxiliary equation and complementary function. So we have to write the auxiliary equation is what happened? Tell me. M square minus p square is equal to 0. Correct? It implies that
Yeah.
m is equals to square will go that side, becomes plus or minus p. Now two values of m we are getting and both of them are different. Write the solution. X is equal to, because pi you are not getting, right hand side value is 0. C1 e power px plus C2 e power, but C1 is already we have taken here. Take C2 e to the power of px plus C3 e to the power of minus px. This is the value
Yes.
of capital X. Now I got the solution when k is equals to t square, which is a positive number. So the complete solution is, therefore, the complete complete solution of equation number 1 when k is positive is u x comma t is equals to c dash e to the power p square c square into t into c2 e to the power of px plus c3 e to the power of minus px. This is called it as equation number 6 here. We have one more case to deal, that key is called case number 3. Case 3, when k is negative. When k is negative, it means that we have to take k is equal to minus p square, where p is any number, where p is in number. So what happened to equation number 3 and 4 we can see. I will show you once again. Here, take the page number 1. Yes, yeah. If you put k value is p minus p square, you will get your answer is p dash by t is equals to minus p square c square, correct?
Yeah.
T dash by t is equal to minus p square under c square. that after this step, you know that already we have done in positive case, same thing, integrating differentiation of denominator and denominator, we write it as log t is equal to, but since it is integrating with respect to t, you will get the variable t and some arbitrary constant, call it as c1. E will go that side, log will go that side, becomes e to the power of this entire value, e to the power of minus c square t plus c1. So we can break this value into parts. That is, part number one is we take it as e to the power of c1 in one part into e to the power of minus c square, c square t is another part. For our convenience purpose, we are going to take this one as c dash again, e to the power of minus c square into t. This is one solution we got it. One solution we got it. For another
Yeah.
solution, you can see the page number one again. Here I am going to substitute k value is minus p square. This together becomes x double dash plus p square into x, right?
Yeah.
X double dash plus p square into x is equal to 0. We have to convert this into the higher order linear differential equation form. For that purpose, we have to convert into the operator form, that is d square plus p square into capital X is equal to 0. Last case only I wrote that d value is d by d. Again, no need to mention. The auxiliary equation is the auxiliary equation is m square plus p square is equal to 0, which means that m square value is negative and then m value is plus or minus ip, imaginary part. So when writing the solution, capital X is equal to C1 already involved here, C2 cos Px plus, the imaginary part solution, complex roots,
Yeah.
C2 plus C3,
See,
already we have done already, na?
please, yeah.
C3, C2, C3 sin Px. This is called another thing. So we have to write the complete solution also in this case again. The complete solution of equation number one is ux comma t is equal to ux comma t is equal to, first solution is c1 e to the power of minus p square into t into, now second solution is c2 cos px plus c3 sin px. Okay, this is called it as seventh equation of seventh equation.
Yeah.
So we got three different equations. Equation number 5, 6, and 7. So you can see equation number 5 is involving only x terms, algebraic form. Here it is exponential form, and here it is trigonometric form. So actually what happened here is, like for example, I will give you one detailed explanation for this one. Suppose this is, we are going to assume a plate is placed here in coordinate axis. Suppose this is a plate, or you can say any metal atom which is kept here on the coordinate axis. So and heat is going to be applied. So the heat is going to be applied after a time 0. The body will be acidic, and when we start giving the heat from any one of the sides, the body is going to be heated. But after one stage, it is again decreasing. It means where it is the concept of increasing, decreasing, you will get it in sine and cos only. After one
Yes.
stage, if t time is 0, there was no effect on the body. But when you
Yes.
apply heat, the temperature will be increasing. After a
Right.
stage, again the temperature will be decreasing. The concept of
Yes.
increasing, decreasing will be there in these graphs only. So then equation number 1 is the only solution which will become physically the solution of heat equation. Then we have to stop our answer by writing since physical, these words finally compulsory we have to write. Physical physical nature of any any heat flow, heat flow equation, heat flow equation are showed showed by seventh equation. Therefore, equation number 7 become become complete complete solution of heat heat. There is one more small concept is left in here in this unit number 2, that is classification of PDE. Which type of equation is this? That is
Yeah.
that hyperbolic or elliptical or parabolic. For that one, I think a small class is needed, and nothing is there except this concept in your syllabus. In unit number 2, this is important concept only: separation of variable, wave equation, heat equation, and we have a different problems based on it. The concept is this only.
Okay.
Classification, if you did, we'll do it some more question in this classification. So then this unit will be completed. If you want, I will go for bisection method also. That is unit number 3. And if you don't want, your choice.
Okay.
Bisection method, Newton-Raphson method. If you want, we can start from tomorrow from bisection method. Unit number 3, we can start. This will be a very lengthy problem, bisection method. You have to be get ready with the calculator. After a
Yeah.
successive approximation, after 15th or 16th stages, sometime you will get your answer.
Okay.
So if you are ready, then tomorrow small concept classification, then immediately we have to start the bisection method. Bisection method, one class. Newton-Raphson method, one class. Okay. And Gauss elimination method and LU decomposition method together one class. Gauss Jacobian Gauss Seidel method will take one class.
Yeah.
So 3-4 classes is required. These topics are one problem or two problem. We can do it in one session because the problems are very lengthy here.
Yeah.
Okay, actually from third, fourth, and fifth, it is only one unit only before it was separated. But now in your
Yeah.
syllabus it is separated. So no problem, I can do it. If you have time, then we can have the class tomorrow again. Tomorrow by 11 o'clock, because I waited for your class from 10 to 11, 1 hour is wasted. Then Fazila joined, so we have the class. We had the class.
Yeah.
But if you are ready now, tomorrow 11 o'clock sharp, then I will give some other time to Fazila.
Okay. 11 o'clock, right?
Yeah, 11 o'clock.
Okay.
So we meet tomorrow again 11 o'clock and we can continue. After classification of PDE, we will do one thing. I will send one PDF about the classification of PDE. If you understand with that PDF, that's well and good, we'll go for a direct bisection method. Otherwise, if you don't understand that, we will explain briefly, then we'll go for bisection method. Okay, choice is
Okay.
yours. But right now, this meeting will be, I want to stop. This concept is over. Okay, just practice the questions. The questions will be, it
Yeah.
is standard type questions only. The questions will not be going to change. Standard equation is this only. The solution will be this only always. Okay.
Okay.
I
Yeah.
am using my own method to solve. टेक्स्ट बुक में आप देखे तो ऐसा मेथड नहीं रहता, आपको इजी करके
In
बता. Okay,
in what?
about these two methods, in heat equation, in wave equation, what type of solution, what method I am using, this type of method is not there in the textbook. Textbook is very
Okay.
complicated.
Yeah.
Okay, I made it easy for you.
Yeah.
Tomorrow we'll see again for bisection method. Okay, and now right now I am sending you that PDF of classification.
Okay.
Okay, right.